Hello, hope everyone's doing well. This is 9.09 geometry lesson. This is on law of sines. So we talked last time about SOHCAHTOA, which can only be used in right triangles. Law of sines can be used in any triangle, including a right triangle. The only criteria is that you have to know a side across from a given angle. So if I know, let's say, this side is 12 and this angle is 32, and let's say this angle is 60, and I'm looking for another side over here, then I can use law of sines because I know this side is 12 and the angle across from it is 32. I have values for both of those. This is the formula for it, but when you use the formula, you're really only going to use two of these at a time, and you're going to cross multiply to solve it. So let's look at number one to put that into action. Draw a picture for each label with the known information. In triangle ABC, we have angle A, capital A, is 115. And then uppercase B, angle B, is 15 degrees. Lowercase b, which is across from angle B, has a side length of 6. And we want to find side A, which is across from angle A, which means over here is C. Round your answers to the nearest tenth. So first thing I'm asking myself is, do I know a side across from a given angle? So do I know a side across from a given angle? And the answer is yes, I do. I know side B and I know angle B. Therefore, I'm going to use law of sines. Okay, so to set that up, and first I'm going to do it using the letters, but we won't always start with the letters here. So I've got lowercase b over sine of angle B, and I'm looking for A. So I'm going to set that equal to lowercase a over, I don't know why my vertical and horizontal lines don't like to show up, but that's our formula that we're going to be using. So let's substitute in. So I've got side B is 6 over sine of the angle across from it, which is sine of 15, equals lowercase a, which is side A, over sine of 115 degrees. Now we're just going to cross multiply and solve. So remember, the variable should always go in front of the trig function. So a times sine of 15 equals 6 times sine of 115. And to solve for a now, I'm just going to divide both sides by sine 15. Now, if you go to your calculator, you're going to use your alpha y equals and type this in. So you'd go to alpha y equals, enter for n over d. In the numerator, you're typing in, oh, and other very important thing, make sure you're in degree mode. So in your numerator, you're typing in 6 sine 115. Close that up. Over sine of 15. And then hit enter. And then you're going to write that whole decimal out. So a is approximately 21.010222635. And again, make sure you're in degree mode. So to the nearest tenth, it said, is 21.0. And yes, you do have to write that 0 because it's a placeholder. Number 2. So number 2, same idea, a little bit trickier. If you're feeling pretty good, pause it, try it on your own. If not, I'll go through it with you. So again, we're going to draw our picture. Angle C is 103 degrees. Capital B, so that's angle B, is 28. Lowercase b, that's side B, is 26. And we want to find side A over here. So when we set it up, first we ask ourselves, do we know a side across from a given angle? Well, I only know one side, and that's side B. But I also know the angle across from it. So that tells me I can use law of sines. So I know I'm going to set up I'm going to use the B's. So 26 over sine of the angle across from it. So that's going to be 26 over sine of 28. But I'm looking for A here. So normally if we were just setting it up, I would say, okay, let's do C and do side C over sine of 103. But since I want A, I want to not have to find any extra steps here. So I want to use A, which means I need to do sine of angle A, but I don't know angle A. How could I find it? Well, I know that there's 180 degrees in a triangle. I've used up 103. I've also used up 28 degrees. So that means I have 49 degrees left. So now I found angle A. I can substitute that into my law of sines and now cross multiply. So I have A times sine 28, make sure the A goes in front of that, please, equals 26 goes first, then sine of 49. To solve for A, we're going to divide both sides by sine of 28. Put this in your calculator. Again, use your alpha y equals to type this in. 26 sine 49 in the numerator, sine 28 in the denominator. Hit enter. We should get 41.7968855. This says round to the nearest hundredth. So that's 2 decimal places. So I'm looking here and say, oh, but that 9's got to round up. So it's going to round to 0.80. 41.80 for A. The next 3 problems are application problems. So these are ones that have been on past Regents exams where a couple of them you might have a choice whether to use SOHCAHTOA or law of sines, but often students find that law of sines is easier. Sometimes the hardest part about these is just reading them and sometimes drawing a picture or reading them and labeling your picture. So number 1 says an airplane traveling at a level altitude of 2,050 feet sights the top of a 50-foot tower at an angle of depression of 28 degrees from point A. So they've labeled right here the 2,050 feet is a level altitude. So the altitude is the height. It sights the top of a 50-foot tower. So this tower is 50 feet tall at an angle of depression of 28 degrees from point A. So here we are. Here's our horizontal line of sight. And we have our angle of depression. Now remember, we talked about angles of depression are always outside of the triangle. And they're your look down angle. So that's from your horizontal line of sight outside the triangle will be 28 degrees. Now I'm also going to connect this 50 at the top of our tower. I'm going to go straight across to make this into our right triangle right here. Let's continue reading. After continuing in level flight to point B, so the plane keeps flying level, and the angle of depression to the same tower down here is 34 degrees. So now I have my horizontal line of sight, and then the line down to that tower creates my other angle of depression, which is going to be 34 degrees. Find to the nearest foot the distance that the plane traveled from point A to point B. So from point A to point B, I'm going to call that X. So at this point, I've labeled everything I know. I want to just kind of find anything else I possibly can in the triangle. So one thing I might notice is here, I'm really looking at the triangle right here. So from here to here, so I'm looking at this triangle. So I only want this piece, not the entire 2,050 feet. So I'm going to say, okay, well, the tower's 50 feet up. So 2,050 minus 50 is going to give me 2,000 feet. So I know that's that right there. I also am going to look here for some alternate interior angles. So I've got this 28-degree angle, means my angle of elevation inside the triangle is also 28 degrees. I could say over here, and you know how small I can write, but this blue angle is 34, and I see a supplementary angle next to it, so that angle is going to be 146 degrees right here. And here I could do, I know this is 90 plus 28, subtract that from 180, or I know that these two here are making a right angle, so do 90 minus 28 is going to give me 62 degrees in there. And that means I've got in this triangle right here, I'll trace it in gray. It's like a very narrow triangle. I've got 2 out of my 3 angles there. So I could do 180 minus 146 minus 28, which will give me 6. So that's 6 degrees in there. All right, so I've found pretty much every angle I possibly can. And I found one side. So there's a couple things I might be thinking. One, I have a right triangle down here, so I could potentially use SOHCAHTOA. I also have a side over here. This side is 2,000 feet, and I know the angle across from it in this red triangle is 28 degrees, so that tells me I can use law of sines. So let's try law of sines on this one. So I'm going to take 2,000 and set it over sine of 28 equals. So I can either find this side down here or this side up here. Now I'm thinking I would rather find this side up here, the squiggle one, because if I do that, then maybe I could use law of sines again in that narrow triangle to find AB, our x value, because I see that this squiggly line here is part of that narrow triangle, where the side down here is not a part of that triangle. So I might not have anywhere to go if I were to find that bottom side. So I'm going to call this side over here, let's call it M. So I'm going to do M over sine of the angle across from it, which is that right angle, so 90 degrees. Now we're going to cross multiply. So I have 2,000 times the sine of 90 equals M times the sine of 28. Divide both sides by sine 28. And we're going to put that right into your calculator. Again, make sure you're in degree mode. And it should give you 4,260.108936. Again, there's other ways to do this. If you wanted to use SOHCAHTOA and you did sine of 28 equals 2,000 over M and then cross multiplied, you'd get the same answer. Okay, so now I don't want to round this. I want to keep that a long decimal because that's not my final answer. I'm still looking to find x. So now I'm going to focus my attention on this blue triangle right here. In this blue narrow triangle, I now know side M, and I know the angle across from that is 146. So I'm going to use law of sines again. So I'm not going to write out my whole decimal. I'm just going to use that letter. So M over sine of 146 equals, I'm looking for x over sine of the angle across from x, which in that blue triangle is 6 degrees. I'm going to cross multiply. So in my calculator, I'm just going to use that entire decimal. So you could arrow up and hit enter to repeat writing that decimal right in your calculator. and then hit times sine of 6. And then to solve for x, we're going to divide both sides by sine 146. And again, write out your entire decimal. And then round it. It says this time to the nearest foot, so 796 feet for your final answer. So we had to use law of sines twice, or you could have done SOHCAHTOA once and law of sines once. So you still would have gone to this next step after that, if that was the way you initially had started it. Number 2. A lighthouse is built on the edge of a cliff near the ocean, as shown in the accompanying diagram. From a boat located 200 feet from the base of the cliff, so that's already been labeled, the angle of elevation to the top of the cliff is 18 degrees. So that's down here, you'll see labeled. And the angle of elevation to the top of the lighthouse is 28 degrees, also labeled for us. What is the height of the lighthouse X to the nearest tenth of a foot? Again, you have a couple different options on ways you can solve this. We could use SOHCAHTOA, and we could also use law of sines. Since we're working more on law of sines today, I'm going to start with that, and then I'll mention how to do it using SOHCAHTOA as well. So when I'm using law of sines, I'm first looking for, do I know a side in the triangle? Because if I don't know any side, then I can't do law of sines. So here I know that this side right here is 200 feet. And in order to use law of sines, I need to know the angle across from it. So I don't know that at this point. So let's look and see what we can find here. A lot of times with these problems, it's just about kind of diving in and start finding anything you possibly can, and hopefully something will help you from there. So I know we're going to assume that this cliff sits at a right angle, as does the lighthouse up here. And the lighthouse would be if that line continued. It's a right angle to just this right here. And then I know in this bottom triangle here, let's use this as the blue triangle, I have 180 degrees. So I could subtract 90 from that, which gives me 90, and then subtract the 18, which leaves me with 72 degrees up here. Then we could also find this smaller angle. Let's make this triangle the green one right here. So we've got this angle. If we do 28 minus 18, that's going to give us 10. And we could do a couple of things here. We could then do 180 minus 72, which gives us 108, which is right here. And then subtract those from 180, which will give us 62 for our other angle. So first thing I like to do is just kind of find all of my possible angles. That way I have them to work with as I need them. So now I look again at this blue triangle and say, okay, again, I have that 200 feet. Now do I know the angle across from it? And I'd say, yes, I do. I also could look at this big triangle here and say, I call this the red one. I might say, okay, well, I know I have 200 is across from the sine of 62. And then I could find this whole side. Maybe let's call this B. And I could find that over sine of my 28 degrees. So if I found side B, then I would need to find this side down here. Let's call this part A. And then I could subtract them. And that's how we're going to do it if we use SOHCAHTOA as well. Or I could say in the blue triangle, I know I've got 200 over the angle across from it, which would be 72 degrees, equals, and find maybe this side that they both triangles, the blue and the green triangle, share. Let's call it G. G over sine of 90. And then you could cross multiply, equals G times sine of 72. Divide both sides by sine of 72. Type that into your calculator. And it gives us approximately 210.2924448. Once I find G, now I can focus on the green triangle and say if I take G over the angle across from it in the green triangle, which is sine of 62, equals X over the sine of the angle across from that, which would be 10 degrees. And then again, cross multiply. So G times sine of 10 equals X times sine of 62. Divide both sides by sine of 62. And then again, that G is stored in your calculator, so just grab that, hit enter, times sine of 10 divided by sine of 62. Write out your full decimal, and then round. This is to the nearest tenth. So 41.4 feet would be your final answer for X. Now, if you had wanted to do it using SOHCAHTOA, you could do that using, and I'm not going to do out all the math, but you could do the tangent. So in the bottom blue triangle is a right triangle, so we can use SOHCAHTOA there. So you could have done tan of 18 equals A, opposite, over adjacent. Found your A, which would be 64.98393925. Then you could have done your big red triangle, which is also a right triangle, so we can use SOHCAHTOA in that, and done tan of 28 equals opposite, which is B, over adjacent, which is 200. Cross multiply there, solve for B. Once you solve for A and B, then you would just subtract them and do B minus A, which would give you rounded 41.4 feet again. So you get that same answer. This is just another way of doing it. So what the beauty of these is that there's multiple ways. There's a couple of different ways you could do it using law of sines, and there's also the way using SOHCAHTOA. All right, and apparently it left a lot of these little marks as I was writing. So go ahead, try pausing this one, and because the hardest part is really trying to read it and figure out how to draw this one. So pause it, try to see if you can draw a picture here and label it. All right, so we've got a ship captain at sea. Here uses a sextant to sight an angle of elevation of 37 degrees to the top of a lighthouse. After the ship travels 250 feet directly towards the lighthouse. So here's my lighthouse. As you can tell, I'm a very good drawer here. And your lighthouse is going to sit at a right angle. We assume it sits at a right angle. We've got an angle of elevation of 37 degrees to the top of that lighthouse. Then our ship, which is over here, travels 250 feet directly towards the lighthouse. So we stop there and we make another sighting. So we've gone 250 feet, and the new angle of elevation is now 50 degrees. So we're closer. Think about at the movie screen, at the movie theater, when you're far back, you don't have to lift your head as high. But as you get closer to the screen, you're going to have to look up higher. So your angle of elevation is going to increase. So we've got that as 50 degrees. The ship's charts show that there are dangerous rocks 100 feet from the base. So we've got these rocks over here, and they go out 100 feet from the base of the lighthouse. Find to the nearest foot how close to the rocks the ship is at the time of the second sighting. Okay, so we're looking for how close to the rocks the ship is as its second sighting. So here's the first sighting, here's the second sighting. We want to know how close we are to these rocks. So we really need to find our distance from the lighthouse right here, really from this right angle. Distance from our lighthouse, and then we can subtract that 100 to see how close we are to the actual rocks. All right, so again, you've got a couple right triangles here. So you are welcome to try using SOHCAHTOA, but we're going to do this using law of sines, which seems to be usually most successful for students. So the first thing I do is I look for is there any side length that I know? So the only really part of the triangle that I know is this 250. So I'd ask myself, what triangle is that 250 a part of? And it's really only a part of this triangle over here. So I look at this triangle first, which is not a right triangle, so I cannot use SOHCAHTOA once I figure this part out. Now, again, I like to find all my missing angles so that I know what I'm working with here. So I've got the 50 as supplementary to this angle. So this is going to be 130 degrees. Then I'm going to subtract 37 and 130 from 180. That leaves me with 13 degrees. Then I know I have in this green triangle over here, oops, thought I clicked green triangle over here, I have a 50 degree angle, and I have a 90 degree angle, which leaves me with this angle up here as 40 degrees. So first I find all my angles. Now I'm looking at my red triangle, saying I have this side. Do I know the angle across from it? Yeah, that's 13 degrees. So that tells me I can use law of sines. So I'm going to do 250 over sine of 13 degrees equals, and I have two options. I can either find this side over here and then use this large triangle for my second law of sines, or I can find this side in the middle here and use the green triangle for my second one. So I'm going to use this middle one because I want to use the green triangle because I want to find that side A here. When you could use the big triangle was if you're looking for the height of the lighthouse, and then it wouldn't matter. So I'm going to call this one side B. So I'm going to do lowercase b over, so I have to stay in this red triangle. The angle across from B in the red triangle is 37, so it'd be sine of 37. Then we're going to cross multiply. We've got 250 times sine 37 equals B times sine of 13. Divide both sides by sine of 13. Again, use your alpha y equals. Write out your entire decimal for B, which I got to be 668.8288536. Now, again, I'm looking for this side over here, which we're going to call A. So to find A, I know now side B is in the green triangle, so I'm going to use that over sine of the angle across from B in the green triangle, which is 90 degrees. I'm looking for A, which is across from 40 degrees, so over sine of 40. Now I'm going to cross multiply. And I have b times sine 40 equals a times sine 90. I'm solving for a, so I'm going to divide both sides by the sine of 90. Again, type that right into your calculator using that full decimal for b. Please do not round that. Write out your entire decimal for a. And before we go rounding a, think about, we just found this whole distance right here, from here to here. So we were asked to find how far we are from the rocks, not from the lighthouse. So that's how far we are from the lighthouse. The rocks stick out 100 feet. So we're going to subtract 100 from that, which gives us 329.9149001. Now you can round that to the nearest foot, which is 330 feet, and then you're done. All right, I hope you guys have a good day. Stay healthy, love math, Pi out.